Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. E2 elimination requires anti-periplanar geometry between the leaving group, Br, and the beta hydrogen, or beta deuterium, being removed. The reaction proceeds via a concerted SYN periplanar or anti-periplanar mechanism. For E2 anti-periplanar is strongly preferred. Moving on to the next step. Identify the stereochemistry of the starting material. The starting material is a substituted cyclohexane with Br and D on the same carbon, C1, and adjacent carbons bearing H atoms. Reading the wedge dash notation, at C1, bearing Br and D, Br is on a bold wedge, axial or equatorial up, and D is on a wedge as well. The CH3 group is on a dash at the adjacent carbon. The H atoms on the neighboring carbons are shown with specific stereochemistry. Moving on to the next step. In E2 elimination, the base, KOH alcohol, abstracts a beta hydrogen that is anti-periplanar to the leaving group Br. The molecule must adopt a conformation where Br and the beta H, or beta D, are anti to each other, 180 degrees dihedral. And for the final step, determine which beta hydrogen is anti-periplanar to Br. Given the stereochemical arrangement shown, the deuterium D is on the same carbon as Br, geminal, so it cannot be the beta hydrogen. The neighboring H atoms must be evaluated. The H that is anti-periplanar to Br in the preferred ring conformation will be eliminated preferentially. However, because of the kinetic isotope effect, CH bonds are broken faster than C to D bonds. But the question asks for the major product based on anti-periplanar geometry. Elimination of Br with the H on one side gives a methyl cyclohexane without D at the double bond position. Elimination of Br with the H on the other side gives a product where D is retained at the allylic vinylic adjacent position. The anti-periplanar H relative to Br in the depicted stereochemistry leads to formation of a 3-deuterio-1-methylcyclohex-1-Na, where D is at C3 and the double bond is between C1 and C2, with methyl at C1. This corresponds to option C. Option A shows D and H both present at C6 on the same carbon with defined stereochemistry, implying no D was lost but the geometry doesn't match the anti-periplanar elimination product. Option B shows no deuterium in the product, meaning D was eliminated along with Br. This would require C to D bond breaking, which is slower due to kinetic isotope effect, so it is not the major product. Option D places methyl and D on different carbons in a pattern inconsistent with the regiochemistry expected from this elimination. The anti-periplanar requirement selects the H, not D, that is anti to Br, and due to the kinetic isotope effect D is retained. The double bond forms between the carbon bearing Br and the carbon that loses H, giving 1-methyl-3-deuteriocyclohex-1-Na, option C, as the major product. Therefore, the correct answer is C. Therefore, the correct answer is option C.